you have the ideas and you're struggling to communicate it, life gets better in this next unit. We're going to continue playing around with our friend the derivative for like the next 2.5 months. It's all about the derivative. So, while Mr. Kurth is still here, 2 derivative formulas that everybody in there, mama needs to know. Who's got them? There's 2 derivative formulas that you need to know. Miguel knows it, Janaea knows it, Juanco seems to know it. I'm wondering about all the other friends. Sandra, what's one of the 2? Wait, f of x minus, we'll just call that a?
Divided by x minus.
Okay, I like it, I don't love it. I really, really want to love it. Why am I not loving it? Why am I being so darn picky here? F of x minus f of a over x minus a. Salma, why don't I love it?
You have to put limit before it.
Right, you have to, like, the limit means something, right? It's the limit is what's happening.
As x approaches a.
Okay, this is the limit as x approaches a. And what you're going to get out of this is always going to be a number, right? And that number means... Salma, what does that number mean?
I wouldn't say whole.
It means whole. No, it doesn't mean whole. That number means something. That number is telling you...
The slope of the tangent.
This number means, say it with me, tan. Tan. This tan of x equals a. Right? This is also f prime of a. It's the derivative. This is one of the ways that we go and find the derivative. What's the other way? Melissa, what's the other way?
The limit as x approaches h.
Wait, the limit as x kisses h, what?
Approaches h.
The limit as...
X approaches h.
Okay, I'm going to write that. Limit as x approaches h.
F of x plus h.
F of x plus h.
Minus f of x.
Minus f of x.
Over h.
Over h. Like it, don't love it. Like it, don't love it. Really want to love it. Oh, so picky, so picky. One cop. Why don't I love it?
It has to be the limit of x approaches 0.
The limit is what?
Of x approaches 0.
The limit of what?
H.
H?
The limit is x approaches 0.
H?
H approaches
Yes,
0.
thank you. The limit is h approaches 0. And if you do this correctly, what you're getting is an equation. You're getting a function. You're not getting a number, but that function that you're getting is the derivative. It's telling you the derivative at all the points that are out there, right? All the different points on the function. So you get to use this one or you get to use this one. So here's what I want to do. There are 7 functions here. Your goal, you're going to get assigned a function that I want you to find the derivative of. By the end of the period, you're going to be able to find all 7 of these in less than 1 minute. I kid you not. Here are the ones that we're going to focus on right now. Number 1, number 2, number 4, number 5. Cynthia and Janaea, you guys have number 1. Team Claudia, you guys are number 2. All 4 of you are working on number 2. Team Miguel, number 4. Team Alejandro, number 5. Team Abel, number 1. You guys have 4 minutes. Work together. If you finish the one that you're assigned, pick yourself a challenge. Try number 3, number 6, or number 7. 4 minutes. What's up? You look like you're on a break. You look like you're on a break. Don't talk to me about power roll. I want to stretch my calculus muscles, so make sure you get this.
Wouldn't it take the
right, I just want to show off. All right, so I'm doing number 7. So f of x is 1 over the square root of x. F prime. Oh my gosh. Limit as h approaches 0, 1 over the square root of x plus h minus 1 over the square root of x all over h. Are you capturing all that?
Yeah.
Okay. So if I do my little butterfly thing here, this is going to be the limit as h approaches 0, square root of x minus the square root of x plus h over the square root of x plus h all over h. I can do a little keep it, change it, flip it. Limit as h approaches 0, square root of x minus the square root of x plus h. We've got square root of x plus h times the square root of x times h. Don't worry about what I'm doing right now. Just focus on the one that you're doing, and if you finish early, take another challenging one. If I take the limit as h approaches 0 and I try plugging everything in, I'm going to get 0 over 0. It's that indeterminate form. So let me try multiplying by the conjugate. Limit as h approaches 0, square root of x minus the square root of x plus h, square root of x plus h times the square root of x times h. The conjugate, square root of x plus the square root of x plus h, square root of x plus the square root of x plus h. If I multiply out my conjugate, limit as h approaches 0, x minus that guy squared. In the denominator, square root of x plus h times the square root of x times h times the square root of x plus the square root of x plus h. How many guys are done with the one that you're assigned to? Then you're doing either 3 or 6. X minus all this, those guys are going to cancel. I've got negative h in the numerator. I've got all this times that times h. The h's are going to cancel. I'm going to get the limit as h approaches 0 of negative 1 over the square root of x plus h times the square root of x, square root of x plus the square root of x plus h. If I take the limit as h goes to 0, this guy goes to 0, that guy goes to 0, and now I've got negative 1 over square root of x times the square root of x, square root of x plus the square root of x. Square root of x times square root of x is x. Square root of x plus the square root of x is 2 square roots of x. Negative 1 over 2x square roots of x. Excellent. I'm not normally just talking to myself, but I wanted to at least stretch my calculus muscles. I didn't get to go for a walk this morning. All right, so you guys both had number 1? Mm-hmm. Okay, Irene, what did you get for the derivative?
I got 6x minus 5.
Okay, and Cynthia, do you guys agree? Did you get 6x minus 5?
Yep.
Nice. All right, who had number 2? Is that the ladies up front? What did you guys get for your derivative?
3x squared plus 1.
Jessica, you okay there? 3x, all 4 of you guys agree it's 3x squared plus 1?
No.
No. Okay, keep going. Okay, number 4, was that you guys?
Yeah.
What'd you get?
Negative 1 over 2x.
No, that's number 7.
Oh, okay, never mind. Then we got 1 over 2 square root of x.
1 over 2 square roots of x. I can't believe you plagiarized by submitting my work. Okay, number 5, that was you guys in the back. What do we get?
1 over x squared.
Wait, number 5, you got what?
1 over x squared.
Okay, I don't completely agree with 1 over x squared. It should be negative 1 over x squared. Did anybody do 4 or 6?
3 or 6.
3 or 6?
Well, I use that poster. I don't know if that's right.
Okay, so then
4 times.
you cheated elegantly and you get 4x cubed. Hey, Jaylene, give me a second here. Okay, number 6 would have been that f prime of x is equal to negative 2 over x cubed. And number 7 we've got some evidence here that it's negative 1 over 2x square roots of x. How many guys honestly were able to completely work out the one that you had? So all this beautiful stuff that I did, what you were just working on, is the derivative. It is the formal process that you go through to find the derivative. I think why so many folks really like this next unit is that there are some shortcuts, there are some rules, there are some patterns that start to emerge when you've done enough of these. Anybody see any patterns? Look at the original function. Look at those derivatives, especially the first three. Jasmine, what do you see?
That the exponent goes down by 1, and then the first part is multiplied by the amount that the exponent was. You know what I mean?
Okay, Wonka, what do you see?
It's the same.
Okay, but I bet you would use different words than she
So
just said.
then, the degree is multiplied by the leading coefficient,
The degree gets multiplied by the leading coefficient.
and then the degree is taken out.
The degree is taken out like it's assassinated?
No, like you don't keep the degree. Like the degree goes away.
Okay.
And then,
What other patterns are out there? What else are we seeing? Miguel, what do you see?
So, for one of the x that doesn't have a degree gets so it gets subtracted by one of the x's in front.
Can you give me an example where you're looking?
Where the second one?
The second one?
Yeah. So like Juan said, the leading coefficient multiplied by the biggest degree, and then the second x is taken away from the first x, so it becomes a 2.
Okay, maybe. There are 5 derivative rules that I want to talk about in the next 15 minutes or so that are going to fundamentally change your lives. Please make sure you've got all 7 of these copied down. I realize you had a chance to work through 1, maybe 2. Maybe later on you'll go and look at all this beautiful work that I did for number 7. I know I was like talking to myself and not supporting you, but you've got lots of smart people around you. I want to introduce you guys to a couple of derivative rules, but I want you to keep these 7 handy to make sure that what I'm telling you fits what we're actually seeing here. The first of the derivative rules is called the power rule. The power rule, let me erase all this good stuff here. So the power rule works if you are taking the derivative of x to a power. So that's why we're going to call it the power rule. So I'm going to use this d by dx. We've talked about this notation before. What does that mean? It means derivative. And what I put in the brackets is what I'm taking the derivative of. The power rule says that if I'm taking the derivative of x to a power, so think x to the 4th power, x to the 8th power, whatever it is. The derivative of x to a power is I take that power times x to the power minus 1. Or if you want to go a little fancier, if your function is x to the nth power, then f prime, the derivative, is going to be n times x to the n minus 1. Whatever was the exponent got brought down in front, and I subtract 1 from the exponent. This is the power rule. We're going to use the power rule when you have x raised to a power. Okay, so humor me. You guys know Arnold Schwarzenegger?
Yes.
The Terminator?
Yes.
Governor of California?
Yes.
Okay, Cynthia, you okay there? Like, yes, yes, just give me the math, yes. Okay, I want you to channel your inner Austrian. Okay, just go with me. The power rule says, oh, no, I know it is a rainy Friday. I know that there is disappointment, but it was 1 bad unit. We have like 11 more to go. The power rule says,
The power rule says,
if I have x,
if I have x,
Abel, Raised to a power.
Raised to a power.
I'm going to find the derivative.
I'm gonna find the derivative.
By bringing the power down.
By bringing the power down.
And reducing the power by 1.
Reducing the power by 1.
Okay, one more time. The power rule says,
The power rule says,
if I have x
if I have x
raised to a power,
raised to a power,
how do we find the derivative? What do we do?
you bring the power
Bring the power down. And reduce the power by 1. There you go. Abel, thanks for being there for me. Okay, 4 problems, 2 minutes. Here it comes. Y equals x to the 100th power. Find y stick. Y stick really means, this means,
Derivative.
this means derivative. I would hope we wouldn't call it y stick, we'd call it y prime. Right, y prime. So y is equal to x to the 100th. Is that x to a power?
Yes.
Yes. So y prime, the power rule says what?
Bring the power down.
Bring the power down
And reduce the
and reduce the power by 1. The derivative of x to the 100th is 100x to the 99th. Done. It took 5 seconds. I know, it is beautiful, isn't it? She's having a moment. Okay. F of x equals 1 over x squared. I want you to go find the derivative. Some of us already tried it in the do first. The power rule works for x to a power. You only get to use the power rule if you see this as x to a power. Who sees this as x to a power? I see Miguel, I see Brianna, I see Cynthia, I see Alejandro. You see 1 over x squared as x to a power? How? What are you doing?
Guessing solution.
Oh my God, you just said guessing. No. What is it that you know? What do you know thanks to Mr. Kurth and all the hard work he did when he taught you exponents in Algebra 2? Don't make me get him back here. 1 over x squared. Can you write this as x to a power?
Yes.
Salma, how are you going to write it as x to a power?
X to the negative 2.
Is everybody okay that 1 over x squared is the same as x to the negative 2?
Yeah.
Now be careful. That's not the derivative. I haven't done calculus yet. I'm doing algebra right now. I'm asking you to find the derivative. So f prime, I'm going to switch colors to make it clear that I'm doing calculus here. If f is x to the negative 2, how do I find f prime?
Bring the power down.
I bring that power down. Bring that power down. And then?
Subtract the power by 1.
You bring the power down and then?
Reduce it by 1.
Reduce the power by 1. So it's x to the negative 2 minus 1. I see you. Give me a second. And that's good. That's an okay answer. It doesn't have as much meaning as if you clean it up a little bit and negative 2 minus 1 is negative 3. I like that. And I bet Mr. Kurth never, ever would have let you leave that answer. What would he have told you to do? Right? You bring it back downstairs so it's negative 2 over x cubed. 1 over x squared is where you start. The derivative is negative 2 over x cubed. Brianna.
Since you say you were gonna reduce the number by -2, shouldn't it be plus 1?
No. The power rule says if you're taking the derivative of x to a power, bring the power down, reduce the power by 1. Subtract. It was x to the negative 2. I brought the power down and I subtracted 1. Okay? Now, here's the thing. Where's the calculus happening? There's one step of calculus and a whole lot of algebra. 1 over x squared, writing that as x to the negative 2. Calculus or algebra?
Algebra.
Algebra. F prime is negative 2x to the negative 2 minus 1. That's the calculus. Right here is where the calculus is happening. Everything after this is just algebra. It's playing around with my exponents. And if anybody had found the derivative of 1 over x squared on the front in the do first, you would have gotten negative 2 over x cubed. Okay, 2 minutes. Show me what you can do with examples 3 and 4. Okay. Only use the power rule when you're looking at x to a power. All right, so third one, j of x is equal to the square root of x. How many of you guys are pretty convinced that you have correctly applied the power rule? Where are all the folks? Square root of x, how is that x to a power? How is that x to a power, Cynthia?
It's the same thing as x squared.
X squared? I don't agree with x squared. Abel?
I put x to the power of 1/2.
Okay. Square root of x is x to the half power. So if I'm going to find the derivative to find j prime, what's that power rule tell me to do? Bring the power down, and then reduce the power by 1. And right now, while we're still babes in the woods, I'm going to write 1/2 minus 1 as that first step. Okay, there's nothing wrong with that. And then I'm going to clean it up and say, oh, well, that's really 1/2 x to the negative half power. Mr. Kurth never, ever would have let you leave it this way. Right? He'd say, rewrite that as 1/2 times 1 over x to the half. X to the half is really square root of x. So the derivative of the square root of x, 1 over 2 square roots of x. And one of the groups did actually work this out.
Yeah.
Right? Is that exactly what you came up with? You're using the power rule. This is so much faster than this way of doing things. Okay, fourth one, derivative of x. Is that x to a power? Is that x to a power?
No.
It's x to the
1.
It's x to the 1. Right, there's that hidden 1 in there. So I'm asking you to find the derivative of x to the first power. So if I use my power rule, I'm going to get 1, x to the reduce the power by 1, 0. X to the 0 is 1. So the derivative of x is just 1. You don't have to go through this process anymore. If you like that, feel free. Some of you like pain. I would prefer you use the power rule when you get to use the power rule. Let me go.
Why don't we learn this first? Because then I would have made.
Because I want you to appreciate this. I want you to appreciate all the calculus that is happening behind the scenes, because this is just like the cheap shortcuts. Melissa, what's up?
So on the AP test, are we gonna do that or that?
Both. It's going to depend on the question. On the multiple choice, do whatever. Do whatever. Okay, we've got just enough time to throw a few more derivative rules at you. Some of these are just going to be very, very natural. Okay, 2 new rules. You got to keep them separate in your head. If I asked you to find the derivative of a constant, the derivative of a constant is 0. The derivative of a constant is 0. Leave it on my desk. Always and forever, the derivative of a constant is 0. But if we're talking about a constant times a function, okay, then what you do is you leave the constant alone and you just take the derivative of the function. So let's look at this one over here. F of x is equal to 3x squared. Is 3x squared a constant? Is 3x squared a constant? Is that term a constant? No. The derivative here, leave the constant alone. Leave the 3 alone. Now take the derivative of x squared. And everyone's going to tell me that the derivative of x squared is?
2 to the x.
Careful. Derivative of x squared is? How about all the nifty other teenagers in the room?
2x.
Derivative of x squared is 2x. So your final answer?
6x.
6x. Done. When you're taking the derivative of a constant times a function, leave the constant alone times the derivative. Please go find on that front page where we just did 7, find me some evidence that says I'm not lying to you right now. Find me at least one where you see that happen. Is there any one of these where we're using that constant multiplication rule? Abel, which one?
Number 3.
Number 3. Number 3?
Yeah. I mean, 1 is a constant.
Right, number 3, x to the 4th power, what is the derivative rule we're using there?
Oh, it's the first one.
Power.
It's power rule, right? It's x to a power, and the derivative was 4x cubed. It's this guy here. I've got a constant times a function, so it's 3 times the derivative of x squared, 2x, minus 5 times the derivative of x, which is derivative of x. We just did this one. I know it's late in the day. Derivative of x is 1 plus the derivative of pi. 0. Pi is a constant. Okay. All right. So let's do one more. What are we on? Example 6. Okay, f of x equals 5x to the 12th. Find f prime prime. Not f quotation marks. F prime prime. Trust your instincts. F prime prime. What am I really asking you to do for f prime prime? Brianna, what am I asking you to do? What?
Wait, you're gonna find the prime of f.
Okay, we're going to find the prime of f, so that's going to be 5 times 12x to the 11th, 60x to the 11th, that's f prime. Now I need f prime prime.
Do it again.
Do it again. And by f prime prime, it's really called f double prime, but it's 60 times 11 x to the 10th power. And if you want to show off, make it 660 x to the 10th. Okay? Homework this weekend has everything to do with the Unit 1 test. Corrections, reflection, get mom and dad to sign it. If you stop by after school, I'll have yours graded. Okay. Yeah.